Shipwright's Log, Day 14. We've made an immense amount of progress on the ship in such a short time. My crew is to be commended for that. We've finished off several areas of the ship and have even begun to, how shall we say, spruce up the place a little bit with some carpeted areas. We've even gone so far as to carpet some of the lower decks. The ship is really starting to take shape, and I look forward to the progress that we will make in the future. End log. Hello everyone and welcome to Markiron Shipyard, episode 14. Today I'm going to do the programming tutorial that I mentioned previously, plus I'm also going to change out these lasers that I've created. These white beams are almost invisible, but we can do better than that. And we'll see what else I have time for today. So, here's a lens bench. Just going to open the interface with a right click and drop some glass in the center here. That'll make a white lens. Now, for lens modifiers, let's throw some blaze powder. Beautiful. 2, 3 invisible lenses. So, we're just going to drill into the laser block, take out the white lens, and replace the invisible white lens. No laser, but when I walk through it, let me break this for you. If you can see my... Oh no, I seem to have broken something important. But as you can see, the redstone is still on because the laser is still here. If I block it, redstone goes off. So, there's this floor done, and a wall to patch up. But, let's bring the lift down and patch up the top too. So, same procedure, bam, bam, bam. And up here, bam, bam, bam. And as with anything, after I've changed anything, I always run another test just to make sure everything's still working as advertised. Click there, chug, 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 and we're up. And come along up to here and chug, 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 chug. Coming up as planned. So, that's that. Next, let's warp down and get to that programming tutorial. Hello and welcome to my test world. Nice flat area. Some dancing turtles. Believe it or not, these 4 turtles are actually programmed to begin dancing on startup. I've got a big screen here for movie viewing. Those of you familiar with what I'm talking about will get it. So this is the prototype I built of my very favorite cargo lift. If I had the program running, I could punch this and it would come up just the same as before. But let's get into what we're here for, which is all this lovely, yummy code. I'm not going to get deep down into how you program. There are much more capable people for that. I'm just going to tell you what I've got doing what and give you kind of the high-level version. If you want to drill down a little further, let me know and I'll send you the code to take a little look at. So, first thing we've got to identify is what our inputs are. So, we've got white and orange. Now, on these blocks, I've got all the colors laid out for the first few bits. So, 1, 2, 4. Where's 3? Answer is these are binary. So, 1 is just white. 2 is just orange. 3 is white and orange. 4 is magenta, 5 would be magenta and white, and so on and so forth. If you're not familiar with the binary number system, look it up. I hate to admit this, being a student of the computer, but binary is actually needed in some places. Does come in handy, especially for times like these. So we've got 4, 8, 16, 32, 64, 128, 256, 512, and 1024. All powers of 2. So, what we've got is each of these colors, when brought into either red power or Computercraft Computer, represents certain numerical values. So, I've got white hooked up to one direction, and I've got orange hooked up to the other. So white goes up, white goes down, orange goes up. So sending a 1 is going to send this whole thing down. Sending a 2 would activate the orange and make it all go up. So let's go over to here. Now, this function is the up function. We'll get into what I've done here with local S side. And for anybody who might notice a few familiarities, yes, I did kind of cannibalize the red pulse program that comes with Computercraft by default. Thank you very much to Dan200 for including that. So, we specify we're making a function. In this case, we're calling it up. And we declare 2 local variables, one n_count, one n_period. So n_count is either we convert the string we input to a number, and that's how many times when that comes up later, or if nothing's passed, just 1. Kind of a nice little fallback to prevent the program from ever erroring should there be a mess up. But this isn't a function you'd call directly necessarily, at least not since I pulled it out of its own separate program. So I've got a for loop here. So for n equals 1, so we're starting at 1, to n_count, which is established up here as the number you pass it, do this lovely little stack of code. And this code, all it does is set the redstone bundled output. So it takes the bundled output, sets it to whatever side n side is. Notice up top n side was equal to left. So this would get passed left and 2, which will turn the bundled output on the left side and output the value of 2, which happens to be the orange. So that outputs, as I throw my red morning star on the ground, so that would output a number of 2, which would output orange, which would turn this orange wire on, which would turn all these orange frame motors on. So, next thing, after we turn it on, we sleep for half of the time that has been allotted. In this case, I've set it to 0.8. That's not configurable in this case from outside, but from inside I change it in this one place, and I can change the amount of time between intervals or between pulses. I find frame motors work best with 0.8 seconds. I don't know if there's actually a preferred setting. This was just the one I found most reliable and fired the frame motors, I think, like 99.9% of the time. There was one failure, but I'm not sure if that was a realistic scenario. There was a pretty big lag spike, so And then we just turn the redstone off on line 16 here, and then we go back to sleep. What this end period divided by 2 does is just split this time in half. So we wait 0.4 here and 0.4 here. Then we end out of that. Next function is down, which is exactly the same except for this first redstone set bundled output. It fires S side like before, but now it fires 1. So instead of firing orange, it calls white. Once again, white fires the down all the way up the stack, and they move in unison. So, and once again, I just split the time in half for each. So now, both of those are functions. So when it goes down and looks through your code, it won't automatically run those because they're not being called. What it will do is when it gets to here, this is where the actual code that is running when this program is running. So it's simple while true do. Also known as the number one easiest way to put yourself in an infinite loop. While true, well, if true equals true, it'll keep doing it. So if true is true, it'll do. Also known as it will never fail that check because there's no way inside to pass a wrong answer outside. Which in this case is actually fine because of what I'm going to do with it. I want this to continually run and we can force a break as we go. So I start off with just a simple if statement. If os.pullEvent is redstone, then. So basically what I'm doing is asking the built-in event handling that while this loop is running, don't do anything unless there is a redstone event. And every time this loop runs, it'll check. Is there a redstone event? Is there a redstone event? When that rings true, then all this code in here gets executed. So it starts with, okay, so we've declared a variable input. I probably could make this local, but that's actually bad coding on my part, but we'll go with it. So it does rs redstone.getBundledInput s side. So it looks to figure out the bundled input of whatever side, remember declared above was S side. So it looks to that side and gets the input value. It then reads it. So let me go into a little more on how it gets, or what numbers it gets. So remember how in my last video I said these different levels, it didn't matter so much how much wire I used or whatever, and that the colors I picked were semi-arbitrary? Well, that's true. I've got light gray, cyan, and purple, also known as 256, 512, and 1024. Now, the reason I picked these three is they're all far enough apart that adding these guys in the mix isn't going to break anything. Like if I was doing math values, I wouldn't want anything else interfering, so they're down here at the end of the stack. And I've picked them and wrote them down. Next, I figured out what the combinations would be when each of these buttons get pressed. Now the cool thing is each of these buttons is mapped to another unique color. So we have yellow, magenta, light blue, and yellow. Magenta, light blue, yellow. So I went and I sat down and I did the math. I I know I hate math, but so I figured out, okay, so currently the lift is at the ground floor, which means this sensor is blocked and thus off by the lift. That one and that one are open, thus making contact. So these two signals are on. So 512 plus 1024. Okay, I did that math, whatever that is. That'd be, let's see, 1,536. Cool. 1,536. Next, I look at the values for the buttons. So for instance, light blue is 8. So at the moment the button is pressed and the event will trigger here, this will be on and these two will be on, which tells me that it's on the lowest deck and that I've called it to the middle deck. As you'll be able to see, actually what I'll do is I'll trigger it from down here so you can see it in action. So I trigger that, which turns on those three lights, but at the same time will call the lift to this position. So what does that look like? Actually, I should turn this off before I forget. What does that look like in the code? Glad you asked. So here we are back in the code again, and this is my giant mega if statement. Basically, it goes down the list and starts. If input, which is the value we've got from the bundled cable, if it results to a numerical value of 776, then, and I just make a note here for myself, these double minus signs makes it a comment so that it will ignore there to the end of the line. And I just make the comment that's going from deck C to deck D, down 4. Now down 4 is just a manually calculated value. Okay, if you're at C deck and you want to go to D deck, you're going down 4. Else if lets me continue my series of if statements with another if. So we get down here. Boom. These two here, 1544 and 1552, are both from deck E, which is the lowest deck, to deck C and or D and C. So I've calculated to go from E to D. This will be the number value, so 536 plus, I guess that would be 536 plus 8. In that case, if it gets that combination, go up 5. If it gets 1552, then go up 9, because it must be asking, that means the top button got hit and it's asking the lift to go all the way up. And then I just end the if statement, end the outer if statement, and then end the loop. And that's it. So it's really actually kind of simple to do once you know the logic of it. But it's basically a matter of getting the input from the system, figuring out what number value is, or figuring out what the numerical value is when that button is pushed. Because remember, pushing the button also triggers the redstone event. These ones that are just constantly on don't trigger the redstone testing. And even if I jump through, like if I do that, I've just made these guys flash. But because it will not add up to any of the same values, the code will never accidentally activate by flying through the middle. It will just, every time it might trigger the event, it'll check the logic, but it will never fire the event. So I think that's probably a pretty good ending point here, so I'm just going to finish up. Thank you very much for watching, and I hope to see you next time. I apologize if this was a little logic heavy for some people. I know not everybody's a coder. There are plenty of people who can code better than I can, and there's plenty of people who can do many other things better than I can. But this is just kind of my little stab at programming. Anyways, thanks for watching, and I'll see you next time on Markiron Shipyard.